Nein, GC. Das ist die alte Veranstaltung. Das war die alte Veranstaltung, aber wenn es geht, dann passt. Streamen wir jetzt schon?
Ja, aber mal rausgeschaut, aber...
Wirklich? Jetzt live? Okay, aber das ist der falsche Link. Das müssen wir jetzt ändern. Das müssen wir jetzt überall ändern. Wir haben einen neuen Link. Das musst du jetzt teilen. Ich habe es auf Twitter geschickt. Auf Twitter ist ein Link. Of course we messed up the stream. Of course we messed up the stream. Das. Was an?
Hallo, hallo, hallo? Hallo?
Willst du das auch?
Ist das für Livestream?
Stream for all.
Okay.
Hallo? Hallo, hallo, hallo?
Das.
Hallo?
So. Willst du das auch?
Ist das für Livestream?
Stream for all. Das ist jetzt auf Englisch.
Hallo?
Grüß euch.
Okay. Yeah, so, okay, so hi everyone. This one is going to be in English, if it's not obvious. So welcome, this is the... Okay, so hi everyone. Where is that coming from? Who is that?
No, not me.
Stefan, do something.
Anybody does anybody have the live?
Do something. So, jetzt, test. Do we have the stream?
Stream is live.
Okay, can you hear me? Okay, let's do it this way. Do we have the stream? Was ist das?
HDMI.
Okay.
Mikrofon sind nicht, was habe ich mit
Hast du den Streaming gerufen, Gergo?
Achso,
Mach mal das zu.
das ist der eigene Stream. Ah! du den Stream aufnehmen, oder?
Geht jetzt? So. Test, test, test. Let's wait. Test, test, test.
Ja, weiterreden?
Ja?
Eingeschaltet ist,
Ja.
oder? Genau, weiterreden.
Test, 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 test. Geht's?
Zweiter zugehört, zweiter zugehört.
Ja? 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay.
Let's try again.
So let's try again. Yeah. So welcome everyone. This is .NET Stammtisch. We already wasted 7 minutes, so let's do this very quickly. So this one is going to be in English. The agenda is very packed. We have 4 talks. Plus, we also have a discussion panel at the end. At Meetup, I posted the schedule. This is roughly what we are going to try. So we will have 2 talks, break, 2 other talks, and then we have a discussion panel. Maybe we will do a break, let us know if you feel that we need another break. We can make that happen, definitely. We have 2 things to raffle because we are sponsored by multiple companies today. First of all, there is a JetBrains license that you can win. You can choose one of those. And there is another one, which is a conference ticket. The conference is in London, and we can give you a free conference ticket. So if you want to go to London for a conference, the conference is called ProgNet London, and we have 1 free ticket. It's very important. I already wrote this on Meetup. The flight and the hotel is not included. So we have only the conference ticket, which is still awesome because there are great speakers there. The way you can win is that you can go to our Meetup page, and there are 2 comments. One is for the JetBrains license, and the other one is for the conference ticket. Just write a plus, and with that you are in the pool. The reason we are doing this is that probably not everyone wants to fly to London, so I hope this is a good way to make these giveaways. Basically, that's it from our side. So these are 2 things. The other one is that food and drinks are sponsored by the company STIWA. Many thanks for that. We are very responsible. Yeah. So as very responsible Meetup organizers, we spent the money wisely, and we bought pizza and beer. Yeah.
Yeah, you can grab drinks over there, and pizza should arrive at around 7.
Okay, anything else that we forgot to say? No?
So STIWA will say a few words, and then, we today have 4 talks. 4 Microsoft engineers are going to speak today. We're very excited about that. One of them came all the way from America only for this event now. Not really, but and the other ones are working in Austria for Microsoft on .NET themselves, but they will explain this much better than I do.
Yeah, so maybe just one thing to this, like how this started the whole thing. So I was working very hard on something, which means that I scrolled through my Twitter feed, and I saw that Karel tweeted that he will be in Europe for the summer, and he would like to visit meetups, and I was like, would you like to come and speak? And he was like, yes, and I bring 3 other people. So that's what we have today.
Yeah.
Okay, and then now we are going to hear from Klaus a little bit about STIWA. And again, thanks for the food and the drinks.
Ich glaube, ich habe das, oder? Das reicht, oder?
Ja, das ist für den Raum.
Ah, okay, alles. Ja, hallo auch von mir. Mein Name ist Klaus Marschner, ich und meine Kollegen kommen von der STIWA Group, und wir haben heute das Vergnügen, dieses wunderbare Event mit Drinks und Essen zu sponsern. Wir haben dieses Vorhaben schon seit einiger Zeit, also sicher vor einem Jahr mal versucht durchzuführen. Wir von der STIWA sind nicht in der glücklichen Lage, dass wir Räumlichkeiten in Linz selber haben, deshalb haben wir eben einmal auf eine Gelegenheit für so ein geteiltes Sponsoring gewartet und heute bei diesem möglicherweise Höhepunkt der .NET-Stammtische ist es nun soweit. Freut mich persönlich sehr, dass so viele Leute gekommen sind. Und ja, der Nachteil ist, unsere Marketingabteilung hat dafür ein kleines Marketing-Event eingefordert, das ich jetzt versuche in Höchstgeschwindigkeit über die Bühne zu bringen. Vielleicht ist ja irgendwas Interessantes dabei, ich hoffe es zumindest. Also ich möchte jetzt kurz die STIWA Group vorstellen, weil die wahrscheinlich relativ unbekannt ist, aber wie gesagt, sehr, sehr kurz. Wer sind wir? Wir sind ein österreichischer Familienbetrieb mit dem Hauptgeschäftsfeld der Hochleistungsmontageautomation. Das heißt, die Firma STIWA ist hauptsächlich ein Maschinenbaubetrieb, aber wir haben mittlerweile 8 Standorte in 4 Ländern, wobei das Hauptteil der Mitarbeiter natürlich in Österreich ist. Wir haben aber eben ca. 100 Mitarbeiter, und das ist der Connect zum .NET-Stammtisch im Bereich der Hochsprachenentwicklung und ca. 140 Mitarbeiter im Bereich der SPS-Programmierung und SPS-Entwicklung. Was wir machen, also Hochleistungsmontageautomation, das kann man sich in etwa so vorstellen, wir bauen irgendwelche Produkte sehr schnell zusammen. Also wir erzeugen Maschinen, wo irgendwas ganz schnell zusammengebaut wird. Das reicht von einfachen Kugelschreibern, wie wir sie da vorhin ausgeteilt haben, bis zu ganzen Lenkungen, Lenkeinheiten für Autos. Unsere Hauptgeschäftsfelder sind im Anlagenbau, dann die Produktion mit unseren eigenen Anlagen in Gampern, da haben wir einen ganz großen Produktionsstandort, und natürlich die Softwareentwicklung. Was machen wir im Bereich der Softwareentwicklung? Das sind jetzt mehr so Schlagworte, weil ich will da jetzt nicht so ganz genau drauf eingehen. Wir entwickeln ein eigenes Kader-MES-System und Produktions- und Produktanalyse-Software am Standort Hagenberg. Wir bauen die meisten Engineering-Tools für den Bau unserer Anlagen im Maschinenbauprozess selber, fast alles in .NET eben. Wir bauen ganz viele oder einige so grafische, domänenspezifische Sprachsysteme, das sind zum Beispiel so Beispiele dafür, und das ist eben die Art und Weise, wie bei uns die Anlagen, also die SPS-Programmierung für die Anlagen erfolgt. Das wird durch die Bank grafisch programmiert und dann eben in SPS-Code übersetzt. Die Anwendung, die wir da rechts sehen, das ist auch ganz interessant, die entwickeln wir seit 2003, das ist mit .NET 1.1 gestartet und hat sich halt immer noch bis jetzt gehalten, ist natürlich Windows Forms Applikation, vielleicht auch ein Qualitätsmerkmal von .NET, dass das eigentlich immer ganz problemlos von einem Framework-Version in die nächste überführt werden hat können. Was machen wir nun? Wir sind in einem industriellen Umfeld, also wenn man da programmieren will, echtzeitnahe Programmierung, und in der Entwicklung haben wir halt so Dinge wie Unity-Projekte, fangen wir jetzt gerade an, Webentwicklung, Big Data und KI natürlich, all diese Dinge, womit sich derzeit schon jeder beschäftigt. Ja, und die unterschwellige Botschaft, falls jemand noch nicht mitgekriegt hat, wir suchen auch laufend Mitarbeiter im Bereich der Softwareentwicklung. Wo sind wir? Wir sind eben, Hauptstandort ist in Attnang-Buchheim, haben wir so um die 900 Mitarbeiter, dann haben wir eben den Produktionsstandort in Gampern und unseren Standort in Hagenberg zur Orientierung. Das sollte Oberösterreich sein, das sieht man vom Kontrast her jetzt glaube ich überhaupt nicht, aber wir sind eben gerade in Linz in der Tabakfabrik, und das ist eben so die Aufteilung der Standorte. In Hagenberg, was man vielleicht auch nicht kennt, sind wir im AMSEC-Gebäude beheimatet, das gehört eben zur STIWA-Gruppe und wird so circa zur Hälfte, falls das jemand kennt, von uns genutzt. Ja, Attnang ist als Zusatzinformation exzellent von Linz aus erreichbar mit dem Zug. Man fährt antizyklisch gegen den Rest der Welt, das heißt in der Früh aus Linz raus und am Abend rein. Ja, und das wäre es auch dann schon gewesen. Falls irgendwer Interesse hat oder Informationen braucht oder sonst was, könnt ihr mich gerne ansprechen, ansonsten auf unserer Homepage, und dann gute Unterhaltung beim .NET-Stammtisch, und danke für die Aufmerksamkeit.
So there's
one for the room, and that's for
I'll do
the
that
stream.
one.
Okay.
Oh, I need both?
That's for the stream. Please take that one. The other one is optional.
Okay. Okay. All right, so very quick intro. Thank you very much. I didn't understand. So now we start English, finally. Finally, we start English. I understood only .NET 1.1. Please don't use it. It's kind of, on both core and that stuff. Anyway, probably from the context is what it's used these days, but end of fun. So brief history. We don't have much time, so I'm gonna make it short, quick. History. I started the meetups in 2017, Netherlands and Czech, where I'm from. I was vacationing there, Prague and Brno. This year we extended it actually a little bit to Austria, including Vienna and Linz over here. So as Greg said, actually thank Greg and Christoph, where are they, for organizing this. Thanks very much. He hit me up on Twitter like, hey, you can stop by. I looked at the map and it was like, oh, it's 1.5 hours from where I will be. Actually turned out to be 3 hours when I'm from. So I made a mistake, and I probably wouldn't otherwise be here. But anyway, Linz sounds to be cool, and I visited Dynatrace people and it was actually pretty cool. Just FYI, I'm continuing in October doing tour actually in Australia, down under tour. So that's right now, in the making. It's gonna be hopefully fun, and you should see similar events in the future. Big reminder: you're gonna post a survey after this. I would very much ask you to please fill the survey. Survey is about like, what did you like on each talk? What did you not? What would you recommend the speaker to do better next time? This is how speakers grow. You can see that even established speakers like Steve Gordon, on Twitter as well commented that constructive feedback is something that is actually very valuable. Come to the speakers after their talk, to me, Bernhard, and others, Alex, Viktor. Sorry, I'm not going to name all of them because it's very very valuable for us. That's how we grow. That's how we get better. One quick thing, this year we're actually kind of rolling out with .NET Foundation Open Collective. Open Collective is a way how to make local .NET meetup groups self-funding, even though they usually already have a bunch of sponsors and things. And by the way, thank you for sponsoring this event, obviously. But this is way how to kind of open it to, first of all, to you. If you have some extra money or whatever, you can pitch in, or you can convince your company that doesn't want to kind of have a huge deal with the local group. They can pitch, I don't know, $100. It's in dollars because it's under .NET Foundation in US. Very simple, very easy. So you can see that this is example from the Netherlands event that is hosted by .NET Foundation. Everything in there is actually very transparent. So over here you see like where we got the money from. So we got actually from individual contributors like up to 350, 50, 30. Some people actually gave us $10 or whatever it is. And that outgoing balance is actually, there's a two-level thing that is going to the larger area. And in the larger area, you actually see the spending. So we invited actually in Netherlands 3 UK speakers. So this is how we paid up. This is, you can see how much we paid them for their travel, so that the money is well spent and that stuff. It's overall very, natural and easy way how to see what's happening, where the money goes, and not just that you see the beer appearing over here, obviously. And you can, by the way, see that .NET Foundation was kind enough to give us $600. So you might see, I already talked with Greg that he's interested here in Linz. So if you have your company, please consider that. That's something how you can support local people, and they can maybe, I don't know, invite more international speakers, do something cooler at the events and that type of stuff. Enough about that. Briefly, I'm gonna, this is wrong order. Okay. I'm gonna briefly introduce the speakers. So next speaker is gonna Bernhard. He's a VM hacker, as he says about himself. All of us are Microsoft employees. He's on Monoteam. Alex as well from Monoteam. He's anyway, you can probably read it. You don't need, he's an open source developer on Monoteam. Myself, I'm 14 years on .NET team on various roles. Lately on CoreFX, so .NET Core. On BCL and networking, and Viktor, who's not here with us yet, but he's gonna come from Vienna. I think he's on his way already, and he works actually with me on the BCL team, not reporting to me, mainly on infrastructure. quick reminder or information if anyone is interested in Microsoft actually positions. So this is not hiring event. I don't want to kind of convince you, but I found out that people are not aware there are actually opportunities to work for Microsoft as developers in Europe. This is from our engineering recruiting things. They have positions everywhere in like Prague, Copenhagen, London, probably not in Linz, probably not in Vienna, but you know, other stuff. And by the way, just FYI, .NET team is expanding to Europe, so that's a cool thing. I'm one of the managers actually on the networking team is expanding. We're hiring right now, actually today, yesterday, and tomorrow is the first wave of hiring event in Prague. If you're interested, aka.ms/prague.net. Anyway, end of demo. Thanks, and I'm gonna give room to Bernhard. Thank you.
All right. Can you hear me? Hello, hello.
That's for the
You need to use this.
Oh, this one.
You need to use both.
I need to use both?
Yes.
Hey, okay. What? I need to find out. No, it's not detected.
Why not? Why not?
Oh, now it works.
Do you need a
All right.
clicker?
No, not really. It's fine. Oops. All right. Can you hear me? Perfect. Yeah? Perfect. All right. Let me remove that notification. So my name is Bernhard. I'm part of the Mono Runtime team for 4 years already now. And my journey actually started here in Linz. I was a PhD student at the GKU. And I did some research stuff on compiler and runtimes, specifically on Java. And I then was looking for an internship. I found one at Xamarin in San Francisco, so I spent a year there. And during that period, Xamarin was acquired by Microsoft, and Microsoft made me a good offer, so I stayed there. I didn't went back to university. But this is fine. I had a lot of fun so far, and some stuff I experienced I will talk about today. So I will have a quick intro into Xamarin and the Mono Runtime. Then I have some stuff about things we have to do on Apple platforms. And at the end, I will have a war story on a specific Android device. All right, let's get started. So this is a picture of the Xamarin engineering organization 3 years ago. And this funny guy in the green t-shirt is Miguel Diacaza, and he founded Mono 20 years ago. And the reason back then was that he wanted to bring the .NET platform to Linux for his other project that he had going on, the GNOME desktop. So he wanted to have the C# language available for the GNOME developers. And that went on for some years, and at some point, I think it was 9 years ago, that he and his friends had this idea to bring also C# to mobile platforms, and so Xamarin was born. This was kind of a risky idea back then, because the word on the street was that HTML5 will going to be on the mobile space, and native apps are not a good idea. Luckily for us, that didn't turn out to be true. All right, so what is Xamarin? Has anyone heard about Xamarin here? Please. Okay, great. Is anyone using Xamarin? That's nice. Okay, cool. So for me as a runtime developer, Xamarin is essentially a bunch of C# bindings to the native APIs to iOS and Android. So the idea here is that you don't have like full code sharing between iOS and Android, but you still do the native stuff as you know it when you have done regular iOS development. And yeah, that's kind of Xamarin for me. And then what does this have to do with the Mono Runtime? So first let me try to explain what the Mono Runtime is. The Mono Runtime implements a specification that specifies a virtual machine, or we often also say VM, that implements .NET bytecode or executes .NET bytecode. Where is this .NET bytecode coming from? When you compile a C# source file with a C# compiler, so for example Roslyn, you will get an assembly out of it, and that assembly will contain all this .NET bytecode. And there are different modes how you can execute those bytecodes. So one mode that we have is a just-in-time compiler. So what does that mean? When you start Mono and you pass an assembly to it, it will look up the main method, and then it will use the JIT compiler to turn the .NET bytecode into machine code and then execute it. As soon as the main method is calling something else, it will trigger again a JIT compilation. So it will lazily compile all the methods that are required to execute your application. We have also something else that is called ahead of time compilation or EOT compilation. And that is, you can, before you start your application, you pass the assemblies to Mono, and Mono will compile ahead of time all your methods and store them into an EOT image. And that EOT image can later be used by the Mono runtime when it executes your application. So it will use that EOT image to look up the finished compilation result. And the obvious advantage is here that you can skip the compilation during runtime. So usually what it means in practice, that the startup time will be faster. Oh, the microphone is working now? Okay, damn. In Mono we have two different kinds of EOT compilation, and what I described right now is what we refer to normal EOT, and then we have something else, full EOT, which I will talk about later. And then another mode that we support since recently is interpretation. So interpretation is usually the straightforward way to implement or to execute bytecodes. And it's usually slower, but there's still an advantage to have something like that around. And I will also talk about that later. All right, as I mentioned, the history of Mono is on the Linux platform. But since then, we also had support for other operating systems, also Windows, a couple of mobile platforms, gaming consoles, all kinds of weird architectures. And since recently, we also have support for WebAssembly, so we can actually run the Mono runtime inside of the browser on the client side, which is pretty crazy if you think about it. So what I want to show here is that Mono is very portable and flexible on the kinds of targets it can run, and that's sort of the strength of the Mono runtime. All right, another strength is that you can embed Mono into your own application. So what does that mean? Let me give you an example. Let's say you develop a game, you have a game engine written in C++, and because it's super fast and everything. And then at some point you want to add a story to your game, and you have a story writer, but he only knows C#, and you want to add support for that. So you can take Mono, you can link it to your application, and that during execution of your C++ game engine, you can invoke Mono, pass some assemblies to it, and then Mono will execute that stuff. And you actually also can build an interface between the C# world and the C++ world. So the .NET code can talk to your game. And that is used by game studios, as I just said. There's also another big user of that embedding API. It's Unity. They go one step further. They allow you to write your whole game in C#, but then they will still call out into native code for performance relevant stuff. And then there's Blazor. So Blazor is a whole browser client-side framework on top of Mono. So that's the WebAssembly support I was just talking about. Check it out. They have a pretty cool demo on their webpage. And to close the circle here, another big user of the embedding API is Xamarin. So Xamarin Android and Xamarin iOS are a big user of that. So in a nutshell, Xamarin iOS is really a simple Objective-C app that initializes the Mono runtime and then passes some .NET assemblies to it, and it will run that stuff, and that's how it works. All right, so that's the connection. I will now talk a little bit more about Apple-specific challenges that we are facing. So a couple of years ago, Apple announced iOS on iPhone and iPad. Probably everyone knows that. They have essentially two different platforms that we care about. There is ARM 32-bit and ARM 64-bit. I think the last ARM 32-bit device is the iPhone 5C, so it's probably going to die soon, hopefully. And so we'll talk about this full UT in a second, but there's also something called the simulator. So if you have ever done iOS development, you probably know that there is a simulator shipped. And the simulator can run your iOS apps, but it really runs on your developer machine. So it means it's targeting the CPU in your developer machine, which is usually EMT64. And in addition to that, they don't have any restrictions in terms of sandboxing, so we can just use the regular just-in-time compilation as we would do on normal macOS or Linux. So for that, we don't have to do much. But for devices, it's a bit more complicated. Because on iOS, they had this amazing idea to not allow JIT compilation. What do I mean with JIT compilation? How can you not allow that? So it basically means you cannot allocate a memory area that is writable and executable at the same time. And that's something you need for JIT because you want to write instructions, machine instructions into memory and then later execute it. So the operating system just doesn't allow it. And as I mentioned before, we do have two different kinds of modes for EOT. So this normal EOT mode still kind of relies on having a JIT available at runtime, which we cannot do for iOS. So we have this full EOT thing. And full EOT means, among other things, that it, for example, includes all the trampolines and wrappers into the EOT image. So what is a trampoline? Trampoline is a handcrafted snippet of machine code that is used to glue together different execution paths in the runtime. And we would usually use the JIT at runtime to generate those. Wrappers are kind of the same, but written in .NET IL code. All right, one side effect is that system reflection.emit is not available on those platforms, so on iOS. So you just cannot use it. It took some time to educate our customers that it's not allowed, but you can still write useful apps without that library available. All right, so there's one problematic scenario with EOTing everything ahead of time, so generics are an issue. So we have this example here, which is just an identity method. So it gets passed in a T, and it returns the same T. And in essence, we have three different cases here. So the first case is that T is a reference type. So for example, a string. And what does it mean for a JIT compiler or anything that wants to turn this into machine code? It means that it receives a pointer in the first argument register, and then it needs to move that pointer value into the return register. So the compiler has to follow something that is called calling convention, and that's specific for each architecture. So for reference types, it's just a pointer. What if T is an integer? For an integer, in most times it's exactly the same as the pointer case. So we could actually share the same generated code. But what if t is a float? On most architectures, the CPU has dedicated floating point registers, and we need to respect that. So the floating point argument will be passed in a different register to this method, and also the return register will live somewhere else. So this is for built-in value types, but C# also allows custom value types, so you can define arbitrary big value types, and we need to be able to handle that. So in the JIT case, we would just generate a new instance of this method. So we would have a different generated code for int and for float and for each value type. And in theory, we could do something like a closed world analysis when we ELT compile your application and try to figure out all the possible types for T. But in practice, this can easily lead to code explosion, and we don't want to have that, especially on mobile, because it would increase the app sizes, and that's something our users don't want. So we have something else, and that's called generic sharing for value types. And you can think of it that everything is passed as a reference. So we get passed in a reference to the return buffer, a reference to the argument buffer, and then also the runtime will inject a hidden argument that is a descriptor for the current T. So with that descriptor, you can, for example, obtain the size of that struct. And when you want to move the value from the argument register to the return buffer, excuse me, you can use memcopy for that. But this requires a bit of magic between the caller and the callee. So the caller would be this, it passes an integer in it, and it returns, it expects that the method also will return an integer. So how does this match up with the stuff above? In order to do that, we inject two different trampolines in between. So the first trampoline will inject this hidden argument, and the second trampoline will use that argument to prepare all the buffers and, for example, move that 5 into this argument buffer. And also on returning, it will move the value in the return buffer into the corresponding return register, so that the caller must not be aware of all this magic going on. So this is a bit complicated, but it works. And there's a slight drawback that there's a performance penalty, but it's definitely worth doing it for the sake of code size. All right, any questions? Maybe, no, okay. All right, so I mentioned that reflection.emit is not possible. If you would try to do that, you would get this system execution engine exception, and the runtime will educate you that it's not possible. But this is not true anymore, because a couple years ago we added an interpreter to the mono runtime, and the idea here was initially that it enables system reflection.emit on such platforms, because we had a customer, a rather huge customer, who was requesting this feature, and so we were working on this interpreter. But it turned out that it's actually also useful for Xamarin iOS, because when you use the interpreter, you can skip this whole EUT compilation process, so that saves some time in your init loop. And it also, the next side effect is that it also reduces your app sizes. So that means you can faster deploy to the device. But of course, the interpreter is slower than EUT compilation, but it's like a factor of 10. But depending on how you develop, it probably doesn't matter. In addition to that, if you really want to use system reflection.emit in your release build, we have something that we call mixed mode. And in mixed mode, you can specify in Xamarin which assemblies should be ELT compiled and which assemblies should be executed by the interpreter. And you can go, for example, this extreme that you say all assemblies should be ELT compiled because you want to have the maximum performance. But if you do system reflection.emit at runtime, it will use the interpreter. All right, and this doesn't ship yet with Xamarin iOS, but there's a preview build which you can try out. So if you're curious, you can go on blog.xamarin.com and download it there. Or you wait a couple more weeks, I think. I'm not showing this. All right, so let's move on to the next device. Apple released another platform which is called tvOS. So for us, from a runtime perspective, it's almost the same as on iPhone. They put some restrictions there, but we could work around there, and it's pretty much the same. And actually, we do prefer, like we as the runtime engineers prefer the Apple TV device because it's the only Apple device that has an Ethernet port. So for development, it's kind of stable. That's pretty nice. And then there's the watch, the Apple Watch, which is like kind of a hate-love relationship for me because as a user, I really like it, but as a developer, I really don't like it. And so there are two devices or architectures out there. So there's the Apple Watch Series 1 to 3, which ships with this ARMv7K chip, which is essentially a 32-bit chip. And with the latest series, the Series 4, they introduced a new chip. It's an ARM64 chip, but they use a different API. And that means they still use 32-bit pointers. And that's kind of weird, but there are reasons why you would like to do that. But the pain for us is that there is no other device out there in the world which has this configuration, so we cannot, like buy some Linux dev board and run this configuration there. So we have to do all this work on the watch. Yeah. And another restriction Apple put on the watch in general is that they force us to ship bitcode. So what is bitcode? Bitcode is the intermediate representation of LLVM. You probably have heard about LLVM. It's a compiler framework. And we do actually have some support for emitting LLVM IR, but it still requires a lot of additional work to make it work with the tooling that is provided by Apple. And yeah, so this was a lot of work for us to make Mono work properly on the watch. And luckily for us, it paid off because we could reuse all this work for WebAssembly. And we didn't know that up front, but we were pretty lucky on that. All right, so that was everything I had to say about Apple. So one thing I want to mention about Xamarin Android. So essentially Xamarin Android, or Android is Linux for us, so we can do JIT compilation. There is no sandboxing whatsoever. But there's one thing that we need to be aware of, and that's when we have, I talked about having those native, those bindings for the native APIs. So as you know, Java is also a managed language, meaning that they also have a garbage collector. And when we have some API call to the Java world from the C# world, the Java world will give us a reference into the C# world, and then we will hold this reference in the C# world. And as soon as the Java VM does a garbage collection, it will not be aware of this reference held by the C# world. And when the object gets collected, then that's kind of bad. So we need to do something there, and what we do in the mono garbage collector is that the mono garbage collector will allocate for you a dummy object in the Java world and kind of connect a lifetime with that. That's called garbage collection bridge, and it works quite well. All right, so this is the last thing I want to tell you. This is a war story. Samsung is a pretty popular vendor for smartphones, and when they released the Galaxy S7, we got a lot of bug reports with this message. So we got the system execution, engine exception, SIG-IL, and it was kind of reproducible according to the bug reporters, but there was like a 50% chance that you will hit it when you execute your Xamarin Android app. And we got it a lot, and at some point a co-worker got the device in the US, so a co-worker located in Boston, and he couldn't reproduce the bug, and so it turned out that Samsung is shipping two different devices actually. So there's the US edition, which ships with a different chip than the world edition, and then we figured out that all the bug reporters are people from Europe, so that explained it. And we were then able to reproduce the bug on the Galaxy S7 devices, the S devices, hosted by the Xamarin Test Cloud team. So Xamarin Test Cloud is or was a service. It still exists, but the name today is different. It's a service where you can submit your Android app together with some UI tests, and it will execute it on their devices and then report back the results. And since I didn't have the device yet, I started to submit my own Xamarin Android apps to this service and was hoping to get some logs out of it. And this is I did this 40, 50 times, and I got a bunch of different logs, but there was a pattern, and maybe you cannot see it yet, but you will see it in a second. So what is SIG-IL? I should explain that. SIG-IL is a signal sent by the operating system when the CPU tries to attempt to execute a machine instruction that doesn't have a valid encoding. So it basically tries to execute garbage. And for a JIT developer, that usually rings a bell, that is caching. So on modern CPUs, like the one you have on your phone, they usually have two different caches. They have a dedicated cache for data and a dedicated cache for instructions. So when you write instructions with your JIT compiler, this all ends up in the data cache. And then you want to execute it with the CPU. You have the problem that the instruction cache is still not aware of that. So what you need to do is that you need to flush the caches, and this is a common thing you need to do. There are libraries for that, and this code snippet is actually from the libgcc, and that's what we have been using on that specific device. And so what is this code doing? It receives an address, and it receives a size, and it should just flush that memory range. And it does some kind of optimizations. So if you're familiar with caching on CPUs, you probably know that there are cache lines. So caches do not cache specific byte addresses, but they caching lines. So that's like a collection of, for example, 64 bytes in a row. And the optimization opportunity is here that you don't flush each specific byte, but you flush each cache line. And so since the cache line size is CPU implementation specific. It reads the cache line size on the very first execution and then later caches the cache line size. That's fine so far, but actually that's the problem, because the Samsung Galaxy S7 ships with a chip that has the big little architectures. So the idea here is that you have two powerful CPUs that you can, for example, use for gaming, and then you have 4 low-powered CPUs that, for example, fetch your emails in the background. And it turned out that those 2 CPUs have 2 different cache line sizes. So when you happen to run this request to the CPU, on the very first time on the faster CPU, you would have a larger cache line size. And when you later execute on the slower CPU, that's bad. So now you can maybe see a pattern. Those crashes, this is the instruction pointer here. Those crashes always happen in the upper 64 bytes. And that was kind of the pattern we figured out. And the fix was unfortunately not fixing libgcc, because we don't have control over that and we cannot ship that to our customers. So we had to apply a fix on the Mono Runtime side. And of course, before we tried to figure out this bug, we Googled for that. You know, we Googled for Samsung Galaxy S7 SIG-IL, and we actually found people running into the same issue. It was the Nintendo Wii emulator. And after I made the PR for Mono, I also made a PR to this Nintendo Wii emulator, and it was actually confirmed that it also fixes the problem for them. So that was pretty amazing. So yeah to open source. And that's my last word, so thank you.
Kann ich schon, oder? Warte.
Bist du auf 30 Minuten eingestellt?
Ja, so ungefähr, ja.
Soll ich dir 10 und 5 Minuten anzahlen?
Ich hab's sonst nicht am
Du hast
Rennen.
einen Timer, passt?
Okay. Can everyone hear me? Hello. Perfect. So, my name is Alex. I'm working on the Mono Runtime as a software engineer, mostly on the BCL side. So that's basically like all the system libraries, basically everything you call into from your application. I joined Xamarin/Microsoft about 5 years ago, and also got in via the acquisition of Xamarin. And if you want to contact me, just shoot me an email or hit me up on Twitter. And my talk today is going to be about .NET 5. So I hope everyone has heard about .NET 5. Has anyone watched the build talk? Just a quick show of hands. Okay, good. So you will hopefully learn a little bit about .NET 5 today. So I think we can skip the introduction to Xamarin because Bernhard already did a pretty good job on that. Just a quick overview. The main goal of Xamarin is to provide the .NET bindings to the APIs of the native platforms, for example, Apple and iOS. So you can use 100% of the APIs that Apple or Google provides on either iOS or Android with Xamarin through C#. And our team, or the Xamarin team, also develops Visual Studio for Mac. So if you have a Mac, you can check out this wonderful IDE called Visual Studio for Mac. And everything is based on the Mono framework and the Mono runtime. And we were acquired in 2016 by Microsoft. So this is a quick history of the problem that we're trying to solve. So like back then, and this is 2002 timeframe, life was pretty simple. You just had the .NET framework, and then Miguel de Icaza created Mono. So you basically just had two different frameworks to target. But then about 10 years later, or 15 years later, we are looking at this kind of mess. So you have all these different frameworks and platforms that are not really compatible with each other, like .NET Core, .NET Native, the .NET framework from the Windows desktop, and Mono, which you can also use on the desktop or on mobile. So it's kind of complicated, and that's not really desirable for the developer because it just causes confusion. So what we've basically been focusing on is we had the situation of all these different .NET implementations where each implementation shipped their own runtime, their own base class libraries, and essentially not a lot of that was shared. And we figured out, that's kind of a problem. And we introduced .NET Standard, which for the first time basically allowed you to compile a library, and it would run on .NET Framework, .NET Core, and Xamarin, or Mono. And you basically just compile the library once, and it runs everywhere, which is good. But still for us as the developers, all the implementations are still different. There's basically no sharing between them. And that is obviously a problem because we don't want to waste our time implementing things 3 times on 3 different platforms. So what we're now doing is we're basically bringing everything together and merging it into a thing that we're calling .NET 5. So .NET 5 will bring the best of .NET Framework, .NET Core, and Mono into a single product that basically allows you to target everything. You can target Windows, Mac, Linux, all the mobile platforms like Android and iOS, the game consoles. You can do great web services on Azure or on whatever cloud you want to use, and everything in a cohesive and in a product that makes sense. So that's basically what we've been working on. And another thing that we heard from customers is that the release schedule of .NET is not really predictable. You basically get an update whenever we decide, we want to ship it. And so we are changing that as well. .NET 5, or .NET in general, is going to ship on a predictable schedule going forward. So each November of each year, you will get a new .NET. So in November 2020, it will be .NET 5. In November 2021, it will be .NET 6, and so on. And each second release will be a so-called LTS release. So LTS means long-term support. So if you want to rely on a .NET version that will get support for a long time, then you want to target the long-term support release, because we will make sure that it will be supported and fix any bugs that show up there. Or if you want to just target the latest and greatest and want to take advantage of maybe your own contributions that you make on GitHub, then you want to target the yearly release. And we can also decide to ship minor releases if, for example, some new feature pops up and it's really popular and we want to ship it in the meantime, we can do that as well. So .NET 5 will basically support all application types, everything that I mentioned before. And it will be open source, as obviously, because it will be, it will take the best things of .NET Core and Mono and .NET Framework, and it will support all platforms. So if you want to run it on, like I said, on Linux or Mac or Windows, you can do it. And the big thing for us is it will share one implementation of the base class libraries. So we will have one implementation of basically the system namespace that runs on like desktop, mobile, and game consoles. And we will make sure that it still adheres to .NET Standard. So if you have an existing library that you compile to .NET Standard, it will of course still run. But the big thing for us is that we can basically, we no longer need to split our engineering resources into maintaining 3 different implementations, just use one. And the big thing for you guys will be that everything will be usable by a single tool chain. So for example, if you're familiar with the SDK style projects, the new project format that was introduced by .NET Core, which is like a very human readable and human editable format of the CSproj file format, that will be usable across everything. So even for Xamarin, right now it's not, like in existing Xamarin, it's not possible to use the SDK style projects, but with the .NET 5 work, it will be. And you will be able to do everything with the .NET CLI. So there's a command line toolchain basically that allows you to drive all that stuff if you want to use the command line, or if you want to use an IDE like Visual Studio or VS Code or even some other IDEs, you can use that as well, of course. And .NET 5 will support, like Bernhard mentioned, the just-in-time compilation that we've been using for decades. It will also get the static compilation from Mono, and it will also get the interpreter from Mono. So you can basically pick and choose whatever like workload or whatever scenario makes more sense for you, and then pick the compilation scenario that makes sense for you. And another nice thing is that we will support a single binary deployment. So today, if you want to package your app into a binary that you can copy to a machine that doesn't have .NET installed, you can do that. But what you will get is basically a folder with like 30 or 50 DLLs inside. And that's, for some customers, they don't want that. They just want a single exe or the equivalent on Linux that you can just double click, basically. And that's something that will be possible with this feature. So the way it works is basically that we compress all the assemblies into the single binary, and at runtime we will extract it to some temporary folder, and then it will just run from there. Okay, so this is basically what you can do with .NET 5. As I said before, you can target all these different application targets like desktop with WPF and Windows Forms, which we are bringing to basically the new world. So if you have an application that still relies on Windows Forms or WPF, you can now target .NET Core or .NET 5 with this as well. Or you can use ASP.NET Web Apps applications, host them on Azure or some other cloud. And as I said, all the mobile and gaming environments that we at Xamarin supports, those will be included in .NET 5 as well. So, yeah. So this is actually something pretty new, because for the last 2 decades, .NET, like the official .NET from Microsoft, only supported one runtime, which is the CLR or Core CLR from .NET Core. But with .NET 5, we will actually have the possibility of choosing 2 different runtimes. You can use the Core CLR, or you can use the Mono runtime. And each of them has different capabilities, different strengths, and different drawbacks. So for example, the Core CLR runtime has been for many, many years tuned on being very, very high throughput and very, very basically efficient for running high performance code. Because if you want to have some like web service running on a big machine like Exchange or whatever, you want to have the absolute best performance of that. So that's what Coursera has been tuned. Mono, on the other side, was basically targeting all the mobile and embedded scenarios in the recent years. So we've been tuning for memory, efficiency, small footprint, so your sizes are small because on the mobile device that's very important. And we're also targeting a lot more platforms than Coursera does at the moment. For example, as Bernhard mentioned, we are shipping support for WebAssembly, which is something that I will explain later on as well. And on some platforms with .NET 5, you can actually choose between the two. For example, like on Linux or Mac, you could say, oh, today I want to run my app with Mono because I'm trying something out with that would benefit from it, or I can use the Coursera. And on some application targets, for example, like on iOS, you would only get the Mono VM because Coursera doesn't run there. And that's something that the project system and the toolchain will handle for you, and you don't really need to think about it. There will be some default, but if you basically want to try out and switch between the two, there's going to be a way to do that. And something else that's basically something that we've been doing at Xamarin and that has been necessary for the Android and iOS products is we will be bringing interop with Java and Objective-C to .NET essentially. What this means is that you can basically call into Java or Objective-C code from your .NET code without any kind of emulation or whatever going on. Because that's something we needed to do, for example, for calling into the platform APIs on Android and iOS, and that's something that we will be bringing to the .NET Coursera as well. So if you have, I don't know, some Java code or whatever that you want to call, that's going to be possible. And that obviously means that we need to integrate tracking of all these objects that are existing on either the Java or the Objective-C side, because you don't want for example, the Java garbage collector to collect something that's still being used on the C# side, and the same is true in the other direction. And that's something that we've been working a lot on for Xamarin, so that's going to be beneficial for .NET Core as well. So right now we have a few things that are work in progress. As I mentioned, the WebAssembly support is something that started a while ago. It's actually has made pretty good progress. We have been shipping the WebAssembly support with the ASP.NET Blazor project. And what it does is it allows you to run the .NET code inside of your web browser on the client. So there's basically nothing running on the server side that interacts with your web page. It's all running inside of the browser. And that's one thing that we've been focusing on basically the Xamarin and Mono team. And that will. The other thing that we currently work on is we are right now running or trying to run all of the tests that .NET Core runs against the Coursera runtime, but we are running it against the Mono runtime, so that we can actually ensure that everything that's supported for basically .NET, for the .NET Coursera runtime will run the same on Mono as well. And and then there are a few other things that will come after that is done, because right now we're still working on making sure that everything works, nothing crashes, and once that's done, we can actually focus on bringing all the things that I mentioned before, like shipping support for the SDK style projects, and making sure that the CoreFX BCL implementation is actually as small as as the existing Mono implementation that we have. Because one thing we absolutely don't want is to increase the size of the user's app, because that's something we got a lot of feedback on. That's something you cannot really do. And right now, CoreFX is not as trimmable, so you cannot really strip out that much stuff from it, so the size would be bigger, so that's something we still need to work on. And then something else we announced is that Visual Studio for Mac will run on the Coursera runtime. So because Coursera is more tuned for like desktop workloads, we should get a nice performance benefit of that. So that's also something that is still work in progress and will take some time until it lands. Yeah, so the whole .NET 5 effort was basically we kicked off the effort in December when teams from Mono and Unity and Microsoft met in Boston, and we kind of defined what the whole workload would be, and we basically, yeah, we kind of figured out what lies ahead of us, because this is a very long journey, so we actually needed to strip it down into manageable pieces. And what we did so far is we defined a layer that abstracts the runtime from the BCL side. So there's a very, very tiny piece of code that needs to be different and tuned for each runtime implementation. For example, passing some objects from managed to native and stuff like that. And the goal of that was to basically have like 99.95% of the code in CoreFX should be common, should be absolutely the same across like .NET Core and Xamarin. And so far, we are running basically all the tests that the CoreFX framework gives us. We pass like, I don't know, at least 99-point-something% of that. And we are also taking a look at running like ASP.NET Core apps on top of that mono VM that is using the CoreFX system libraries. And that is looking pretty good as well. And one interesting tidbit about that is we actually started shipping or pushing some pieces of that to Mono's GitHub repository, like basically right when it kicked off, even we didn't announce it yet publicly. And there's one guy from the community, Philip Navarra, who basically saw these changes and figured, oh, that looks pretty nice, I will send a pull request. And so that's what he's been doing and still does today. So he has been actually helping us, even though he didn't really knew what was going on. And yeah, so we were very grateful for that. And yeah, so the .NET Core, the CoreFX master branch right now is fully working, committed and working on the 5.0 target. So all the branches that, because .NET Core 3 is still not released, but there has been branches made, and the master branch right now has switched over to .NET 5 work. And here's a quick state from our CI system. So we're running about 1.2 million tests on each commit. That is just for 3 architectures. So on like the regular mono, we run about 40 different configurations. So those are just 3. And there's still like 1.2 million unit tests. And I think, yeah, basically almost all of them are passing. We did disable a few features that we haven't implemented in the Mono runtime yet, like collectible assemblies, which is needed for the assembly load context API, which is supposed to replace the old app domain API that's not going to be available in .NET 5. And also stuff like hardware intrinsics, because those like need actual implementation in the runtime. But it's still pretty amazing that we can run a lot of those tests and they're passing. Okay, so WebAssembly. How many of you have heard about WebAssembly apart from Bernhard's talk? So WebAssembly is basically a binary instruction format for a stack-based virtual machine. That's how they call it on the WebAssembly homepage. And what that means is that you can compile something down to this WebAssembly format and run it inside of your browser. And it runs alongside JavaScript. So there's some misconception that WebAssembly is somehow transpiled into JavaScript, but that's not true at all. It's basically, it sits next to JavaScript in the browser's execution pipeline, and it therefore is very, very fast. And like we as Microsoft, we're using it in the ASP.NET Blazor project. And there's also community projects like the Uno platform, which is providing some XAML UI implementation that also runs with WebAssembly inside of the browser. And right now we are supporting 2 modes with WebAssembly in Mono. One is the interpreter mode and one is the ahead of time mode. And both of them have different strengths and drawbacks. It's basically similar to what Bernhard said. The interpreter is like has a very fast startup, and yeah, you can basically it it doesn't take long to compile because it's interpreted. So it's very good for fast iteration. For example, if you're developing your app and want to change something and want to hit refresh, and it should basically refresh immediately. But for the actual shipping application, you want to have like best performance and most optimizations enabled, and that's where you would use the ahead of time mode. WebAssembly right now has a few limitations that are kind of annoying, but they're being worked on. So right now WebAssembly doesn't support threading, so you only have one thread, and we need to do a lot of crazy gymnastics to work around that, because as you can imagine, C# likes to have threads, and we need that for a lot of features, so we need to do some workarounds there. But there are some prototypes of threading support already in the browsers, and our runtime engineer, Sultan, I think a few days ago he sent a pull request to turn that on in Mono, and we should be having threading support at some point in the future. And there's also other limitations, like there's no GC integration, so we need to basically bring our own GC, like the garbage collector. And that's something that WebAssembly, I think it's some kind of consortium or something, so it's basically different browser vendors working together on defining what WebAssembly is, and they are looking at all these different gaps and trying to basically address them. I think we have a little time for the demo, right? So I just wanted to quickly show, let me switch. Let me see if I can do that with the microphone. Okay. So let me see if I can make this bigger. Can everyone somehow read that even in the back? So if you want to try out WebAssembly with the ASP.NET Blazor projects, you just have to install some preview bits that you can find on the website, and then you can do, let me actually just create a folder for that. What you can do is use the .NET CLI and run the .NET new command, which creates basically a new project. And you can use .NET New Blazor, and it will basically create a project that is a standard ASP.NET Blazor project, which has a few pages and a few like glue code and startup code and some CSS. And this is basically a hello world application, and with the .NET run command, you can spin up a web server, a local web server that will host this application. And in a few seconds, we should hopefully get some localhost thing here. So this is basically a hello world application that has a few pages, that does a few like simple demonstration things. And the interesting thing here is that everything you see here is generated by the browser, by Mono and the ASP.NET Blazor running inside of this browser tab here. So there's basically no communication between the server and the client going on for like doing all this counter increasing. And if you open the Chrome developer tools and hit the network tab, I'm not sure if you can see that, but if we refresh that, we will basically see that the first thing that this application does is it loads some mono.js glue code and then mono.wasm. And wasm is basically the wasm the mono runtime compiled to WebAssembly. And what this in turn does is it just fetches DLLs. So it actually downloads .NET DLLs that have not been modified and just runs them inside of the browser. So there's actually no crazy JavaScript going on here. Everything is .NET. And this is very powerful because you can actually take your existing like business logic or whatever you have and easily bring it inside of into the web world. And yeah, this is just a quick demonstration. There's a lot more going on, and if you want to try it, there's some documentation on the website. But yeah, I think that's everything I had for today. Okay, and thank you. And I think we'll do the Q&A on the, at the panel discussion, right? Yeah.
All right, thank you. Okay, so a little bit of logistics. We are going to have a break now, and I think we already have the pizza. I don't see it yet, but yeah. But if it will arrive, then it should be at that corner. So we are going to do the break. Hopefully the pizza will arrive, and after that we are going to do the raffle. So we will have the ProgNet London ticket, and we will have the JetBrains license. If you are not on the list, just find me and I can add you to the list and you can win. Yeah, basically that's it. For the stream, we are going to do a break and then we will just go back or come back in around, yeah, so this is going to be like 14 minutes, something like that. 40 minutes. Yeah, that's it.
Okay. So am I loud enough or do I need microphone? Oh. Okay. Is this better? This doesn't work. And now it works. Awesome. So hello, I'm gonna do my talk about war stories from .NET team. It's a talk actually I did a couple of conferences this summer, so and we don't have much time, so I'm gonna cut it out, swap it, and it's gonna be hopefully slightly different than it was at NDC Oslo and elsewhere, if you saw the recordings. So let's start. First of all, I'm gonna talk some stories, not only from me, but some of them I lived through, some of them my colleagues on .NET team, and hopefully there's gonna be some kind of key takeaways that you're gonna take from it and lessons that we learned along the way. What you won't see is any source code, any debugger, and there's gonna be one very crippled, then call stack, so not even full call stack, so don't expect anything like that. Let's go. The first story, which I'm gonna really shorten, because otherwise it's a pretty long one, is actually my first story. I was like 3 months in Microsoft, so it was January 2006, so quite a long time ago. When it kind of kicked in, and what we got was that build lab of some kind of Windows component was hitting roughly once per week a break. They got the access violation dialog, they had to log into the machine, click it off because there was nothing that would kill it, and it was kind of annoying. It was kind of holding the team kind of back, as you can imagine, and that was kind of nasty thing. Eventually they got to us as a CLR team. It started with MS Build said it's C#, C# says no, it's metadata, that's what I owned, that's how it ended up on my plate. Now 3 months in the job, that was kind of fun. The good news is that actually they were able to create a repro. So on one machine they kind of like were able to run it in a loop, and once in 50 times roughly, and then overnight, like with some slightly less percentage, they were able to hit it. Same call stack, everything, and we kind of look at that. We kind of suspected GC because it was actually when you look actually at the call stack, this is the kind of very things taken out of that from the call stack. At the top, you see that there was some kind of compiler calling to the metadata. MS Core Works is the CLR DLL these days. It was like 2.0 time frame. And there was kind of like some destructor calling some unlock read, and that was corrupted over there. So it took us a time, or quite some time, to figure out what's going on. Part of that, actually, we noticed that from call to call, things are corrupted. That was the first step. The next step, actually, we noticed that there was only one bit flipped. So we started, suspecting GC or something like that, but then you find out that actually it's C# compiler, the native part. It's not Roslyn, so GC is not in the play. It doesn't run at all. So there was a full lead. And at the end of the day, we really started suspecting when everything ran out, because nothing in the call stack made sense. It's somebody else had to come and corrupt your call stack, which doesn't make sense. We basically look at it like maybe it's a hardware error. And so we asked the team, like, hey, does it by a chance, reproduce only on one machine? Guess what was the answer? Yep, how did you know? Well, okay, we kind of suspected from the call stack. What was interesting is, why the same call stack with the hardware error was like, it was always the same failure. The machine didn't fail on anything else. It's a good question, and we never kind of found out the answer. It was just like lucky or something like that. So kind of magic that always like one bit was flipped, always in the same call stack. And it took us, I think, like 3 to 5 days to actually track this down. By the way, it's a great way if you ever need to learn x86 assembly and that stuff, like go find some issue like this, that's gonna, force you to kind of find out what's the arguments, what are the parameters, and when locals are stored and everything. The lesson that learned is from this, so I would love to learn that after this one experience, I was wise and said like, oh, it's costly. Well, it is, it's hard. And the key takeaway is like, from since then, or with asterisk, since then actually I keep asking people on, typically on CoreFX issue, on a CoreFX issue, I think when something is suspicious, weird, it should not happen. It's like, does it happen on one machine by a chance? And sometimes you hear the answer like, yes, how did you know? Like, okay, go away. Next, like just take the machine out of the pool. It's not worth it, it's really good, good insights. Now, as I said, like, you know, I wish I was as smart after the first time. It took me one more issue, like I kind of think 2 years later, when I again spent like 1 or 2 weeks debugging something until I found out like, oh, okay, some bit flipped or something, clearly memory issue, one machine problem. And then that's what you kind of start appreciating your time, because investing like 3 to 5, 7 days, whatever, or 2 weeks is just not fun. Well, it's fun one time or twice, and then it's like, yeah, I had my fun. Next set of problems. So that's kind of interesting. It was interesting when I was giving this talk, quite a lot of people came to me and like, yeah, I had something similar, and never occurred to me that I should actually ask this question and things. So maybe you will take it as well for magical things and kind of keep it away from you stealing your data. So that was metadata story. There's another one. I'm gonna first describe some background. So first of all, if you don't know what metadata is, metadata is basically part of your application of your assembly. There's like the IL, the intermediate language, and metadata part. Altogether, they define your program, and it's compiled by JIT, you know, the execution time. And the metadata was a long time ago basically designed as a database. But database people designed it so they knew how to do databases, so they did database. So it has like tables, it has like rows, each tables, and columns. One example is type definition table, which is basically table describing all the types that are defined in your assembly. So there's literally like, you know, each type has one row, and there's columns. For example, one column is flags, another column is like, what's the type name, what's your namespace, what do you extend, I didn't put the details here, and what we're gonna find later on interesting is the method list. Just FYI, the type name is not the name of the type is not directly in the table. There's only index to something else. So all strings are actually on a string heap. So you basically say like, you know, hey, my type name starts at offset, I don't know, 27. My namespace starts at offset 55. And same it is actually with method list. It doesn't, it basically says like, you know, hey, my first method starts at over there. So it says like my first method for the type foo over here starts at, you know, number 10. How do you find out how many methods you have? Well, you look at the next type and you look at it like, when is your method list starts? And whatever is in between, that's you. Or in between, inclusion the first one, right? So in this case, type foo has one method, and that's method 10 only. The method 11 is already belongs to the next one. If it had like, you know, more, it would be, you know, higher number. What's interesting how these things are kind of compressed because we care about size. So, you know, method list and even the type name and things, whenever they point into some other place, either they are stored as like 2-byte or 4-byte indexes. And that's basically defined at the end of the beginning. When you load it up, the metadata, you first look like how many, there's information, hey, there's so many strings, there's so many types, so many methods, and based on that you find out like, oh, how is it encoded? 2 bytes, 4 bytes, simple, right? Definition, you know, does it fit 2 bytes? Then it's 2 bytes. If it doesn't fit, it's 4 bytes. Now, what happens if the type definition has no methods? So imagine that foo doesn't have any methods. How would it look like? The type bar would say as well method number 10. And basically that would explain, it would say like, you know, hey, I start the method number 10, but the next type starts at method number 10, so I have no methods. Now, what happens if the last type definition doesn't have, you know, any methods? So imagine that the bar is the last one, type definition, and if it doesn't have any method. The method 11, here that would kind of index, would have to be the kind of the one that doesn't exist, because it would be the last one, by the definition, that would be part of the type. So it's basically describing that, you know, hey, if you, you know, if you want to express that the last type definition doesn't have any method, you have to kind of look at the how many methods do you have and say it's the 1 plus 1. Now, what happens if there's exactly 64k minus 1 methods and there's a last type? Basically, at that moment, you have to express in the table, hey, my method index is 0xFFFF plus 1, which is overflow. What do you do with that? How do you express that? You know, it's a basically bug, right? What do you do with that? You cannot do much. Basically, you have a chance to go and say like the spec is wrong, let's fix it. Which means that all the tools existing out there or the metadata readers and things have to deal with that. You could imagine saying like, you know, hey, what if we put there the overflow value, which is a 0, But again, all the readers in the world, including Dynatrace, metadata reader and whatnot, all the profilers, debuggers, Visual Studios, writers, and other tools, because almost everyone has their own reader or writer. All those tools would have to kind of change and expect that 0 is a valid value, which normally it's not, because it starts from 1, because 0 is kind of for nil. So that's an interesting case, and just to kind of demonstrate that I'm not lying to you, this is actually directly from the metadata spec. If you look at that, the first one basically said, like, how do you define if it's 2 bytes or 4 bytes? If it's less than 2 to 16. It doesn't say less than or equal. That would be one fix. The type def basically says, like, the valid values are between 1, because 0 is kind of reserved, up to row count plus 1. So that's basically what I just described to you, how it would kind of count for the last method, last type without methods. That's what it says in the text. So how do we fix it? Well, it turns out that bug like this happens roughly once in 17 years, because this is a story from last, I think, June, I forgot about it, or May. At that moment, as Mikhail, who's now the lucky owner of the metadata, said, like, maybe let's not fix it. Let's wait for another one person to kind of hit that. Just out of curiosity, this was some WinMD file from Windows. They're building the WinMD files in their build system. They're adding types and things, and they their build. Apparently the Windows build is. Or Windows component builds is a good test bed for us and for metadata. They kind of like hit this and eventually came to us. So what's the lesson learned from this? They kind of found interesting. That's that not all bugs have to be fixed. If they're rare enough and if they're costly to fix, because in this case, no matter how you think about it, there's actually no way to fix it without breaking the whole ecosystem and telling everyone to change their things and metadata readers and writers, which will take probably 10 years to propagate, because you know how those things long live. You just say, like, whatever, let's live with it. It's a bug, such is life, deal with it. There's actually another lesson I learned with this, because this came to me last year, or to me as well, because Mikhail's like, hey, I think that this is kind of wrong. What do you think? Like, yep, you're right. That this is, I found the parts of the spec. Like, yep, this is exactly wrong. The people who defined the spec long time ago, like 15 or 20 years ago, didn't think about this corner case. The kind of the part that is interesting and I found funny is that no matter when you owned something, because I owned it last time probably like 10 years ago, it's gonna haunt you. It's gonna find you no matter how far you are. If there's a bug and you happen to have any knowledge about that stuff, it's gonna come and bite you. So it did. Another. All right. Next story is actually, this is an old one, 10 years old, from April 2009. And it's actually an interesting one, again, about kind of spec issues, as we're gonna see. It's about interfaces. So in the runtime, now forget about metadata, we're done with that. There's types can implement interfaces, right? You do C#, you've seen that, easy. VB does it too, by the way. So how do we store that? We store basically a simple table, something almost like virtual table, where you have like, index of the interface, so that's easier for lookup, so you don't have to kind of compare strings and things at runtime. You say like, hey, index 0, boom. It's then like directly pointer to the interface I, and if it's 1, then it's J, J. Now, if you inherit from the A and you add one more interface K, how is it gonna look like? Probably no big surprise that you're gonna add one more column in this case, or whatever is it, how is it, into the table, one more entry, I would say, which is gonna be indexed as 2, and then where you expect K. Clear? Right? Simple. That should have no troubles, and it didn't have troubles in the spec until a teeny tiny thing came along called generics. Now imagine that the type looks slightly different. It's C of T, and L is an interface, and you implement interface L of T, generic one. Sure, why not? Then you inherit from that, why not? And you happen to implement L of string, which is a valid. You can try it, simple thing, you can. So how do you express that in this internal thing? You say like, hey, index 0 is L of T, index 1 is L of string. Well, now the evil guy comes along and he said like, hey, D of string. Fun. And actually, just to have fun, he adds, or that person adds one more interface, I, let's say, in this case. How is it gonna be recorded? We're gonna find out that, hey, D of, or L of T, instantiated over string is basically the same as L of string, and we collapse those two things into the 0. Now, I said the interfaces, the indexes are actually used. What they are used for? If you do a call into a virtual method, from the call side, what the JIT basically generates, it says like, hey, when you get the type, because by JITting time, you kind of verify everything is type safe. When you get this type, take interface at index 2 or 0, and please call method at position 5. Because at JIT time, you will find out that, hey, what's the interface index and what's the method index in that specific interface. Now, imagine that somebody actually, there was a call over the L of string in the D of T class, in the second class, right? So somebody called on L of string some method. So what would JIT generate? It would generate like, hey, take the interface at index 1 and call method, I don't know, 2, whatever. Now, if you pass E, you're gonna actually end up calling I, which means that you call entirely different implementation over something entirely different, unexpected data. That's actually a security bug. So how do you fix it? Well, the fix is kind of obvious when you look at that. You have to think about, hey, if I happen to collapse these interfaces, like don't collapse them, like keep them around, because like the previous, your parents are still used to the indexes being 0 or 1. You cannot, you have to keep them both. And that was actually it was not bug in spec, but the spec was vague enough to tell you like, oh, always find out what resolution it is. And we, I didn't have it here because it basically introduced probably, decent 2 pages of language in the spec explaining what you have to do, what the rough algorithm is for resolution of interface call to actually express that, hey, you shall not do the bug that we did. What's interesting on this, and why I kind of introduced it in here, that there was actually, there was first of all, a long existing bug. It came like quite late, like generics were around since at least 2005, probably longer. So it was like 6 old years bug. It was bug actually in the spec, kinda, and it came as a security issue. As a security issue, what you do, you have to fix things as soon as possible. And when you look at that, this is basically a feature, because it doesn't mean that just like, oh, let's not collapse it. Imagine that you inherit from it later on. You override some of those things. You have to find out, oh, so I'm overriding L of string and it's in 2 places, and like keeping track of all that information. It was a really non-trivial kind of feature in the type system. I think it took like 2 weeks to design and then 2 to 3 weeks, implement, which is quite long, by the way. So we did actually, even in servicing branches, sometimes we do small features only when we have to, obviously. That was an interesting part, at least back then. So we kind of got to breaking changes. Breaking changes. Why did we get breaking changes? Technically speaking, suddenly, the stuff working differently was breaking change. Obviously, if somebody relied on the fact that you called the wrong interface, like I don't have much, happy with that. But technically speaking, we introduced breaking change into the specification. The same thing we would want to do with the specification before with the metadata. So with breaking changes, there's actually an interesting thing that everyone, if you find a bug, especially if not in your code, if it's in your code, you probably go and fix it, right? Unless it's the once per 17 year and it's extremely hard to fix. But if you find a code in .NET or in Windows, the first thing you're gonna say like, oh, I found a bug. It took me two weeks. You better fix it. Everyone does that. I do it too, right? The interesting thing that nobody wants to be broken. So when we update patches, especially to .NET Framework, in-place update, we don't ask you kind of like, we push it on not to you only as developers, but to your customers. And suddenly your customers could like, oh, hey, something is wrong like with your software, and you find out that actually was our breaking change. You're not happy. The interesting thing is that roughly 10% is kind of like rough statistics. 10% of changes, some people even say 20% of changes, will cause some, unexpected side effects. No matter how many and how smart people you put on the code reviews and checking, like, it's gonna happen, period. Right? This is quote actually from Jan Kotas, our architect from long time ago. And to demonstrate it, I actually lived through one extreme case when we actually improved performance of type loading of something, and it broke a customer. Of course, like it took us a while to figure out, because first thing we published update and like, hey, you broke us, or you broke our customers, we are very unhappy, you gotta fix this. And we're digging into that. And it turned out that they depended on the order of flow of initializing type. And they had a dependency, by accident, that when they read the value, it's still 0. And we sped up things, and we initialized the thing before they got to run, and when they ran, there was not 0, and that had some side effects, and they didn't initialize it before, and their application didn't start or something like that. They were very unhappy, but that was actually the case when we said, like, you know what, you kind of depended on something that we explicitly say you should not. Obviously, you didn't do the evil, but there's not much we can do. Like, we're not gonna stop making things slower or faster. We're not gonna stop improving just because somebody might be broken. But that's the reality actually we face in .NET framework. We have to be extremely careful whenever we change something. Are we gonna break someone? And I'm looking at Dynatrace people. Sorry for that. But especially tools and kind of things that are frameworks on top of us, libraries, or actually like other kind of layers, are extremely vulnerable to that because they get more of that stuff because they usually do kind of more funky stuff, especially with debugger profilers, and they depend kind of on more things, or their customers have as well like various things. So obviously if we break somebody like that, it looks like that we are the evil Microsoft, we broke them. It's like, nope, sorry, like we just make something faster, like that's not our fault, right? Sometimes it is, but we tried hard not to actually break. The moral thing is that no matter what you do, everything has a risk of breaking someone, which is kind of a little bit eye-opening, at least for me. And to kind of drive home some point, actually I have a couple of stories of like how bad it was. Like one time actually we had this, it was the Windows 8 on ARM, there was the Surface RT, right? That's the thing that everyone has at home still. You use it, right? And there was like finance up, back then it was like, key thing, it was very important obviously. And on the last build, it was like last build of shipping that Windows build, which included our, I think this was with .NET Native, or was it not? No, this was not with .NET Native, it was before that. It was like built, some applications shipped as part of the Windows, including the finance, the Bing Finance, or it was like pre-built or pre-installed. And on the last build, it started failing. So we dug into that because, they didn't know. And it turned out to be actually a bug that was there like for months, except it had 2 triggers. The first trigger was that you had to have a method exactly on the boundary of engine image of 8 kilobytes. So a method had to be there. Like always happens. Usually there's something, but that method on top of that had to be in situation that GC is triggered twice when it's on call stack, which is like basically it has to do something, sit there. Something else happens, GC triggers twice, and then boom, crash. So the finance application didn't start. Now it turns out that some entirely unrelated change somewhere out there just introduced a little bit more code. It pushed out, and we were unlucky that actually the default proxy of system.NET configuration during the startup of the finance application was on the call stack. And when you do the default proxy, you hit the network, it takes quite some time. Lots of applications, including probably finance, like at the startup, like allocate a lot, or kind of like get the data, throw it away, boom, and happened that GC happened twice at that moment. So it kind of bloated, which is, blasted and failed, spectacularly. And I bet you that whoever was introducing the innocent change that just happened to move stuff a little bit farther away was like, hey, you know what? This is super safe. Like, see, the code couldn't ever work. Like, it's clear back. Like, you just add this one instruction and everything works. Like, yep. You did, and boom, something else entirely broken. Now, obviously, you don't have to be that much paranoid always, but that's kind of like another reinforcement. Like anything, literally anything, any innocent thing can can break something. It doesn't mean that it's gonna break exactly you, but something somewhere might break. A story I don't have here actually. My boss and colleague told me that actually he lived through the case that even a rebuild of exactly the same sources, so no code change. Just another build, maybe another day, broke something. Just the fact that it was like burned different numbers, somebody was like relying that it's even or odd or whatever, why would someone ever do that? But anyway, such is life. Software is complex. Some dependency, something just got broken. So again, don't be too paranoid, but sometimes be. It depends, and that's one of the reasons why the closer to shipping we are, the more kind of picky we are at what to fix. Like people come and like, hey, just fix this. Like it's it's clear. It's not gonna break anything. Like, yeah, you didn't hear all the stories. So, how long are we from last build? Like, 1 week, 2 weeks? Like, yeah, what? How important is this? How many customers are impacted too? You know what? No, not enough. Now, obviously, if it's some bug impacting like half of the world, like, yeah, let's fix it. Let's take the risk. But you have to weigh the risk. Anyway, sometimes actually the breaking changes have kind of a huge impact, and this is awesome story actually. I love it at least. Once upon a time, a long time ago, actually, a patch of .NET framework gets pushed out to the world, right? Every Security Tuesday, everyone loves it. Or this was actually like some larger fix. We broke certain tax software. I'm not gonna name it, in certain country, and we broke printing of the taxes. It kind of sucks. And we broke it a few days before the tax season was over. And when you look at that, that's a bad combo. So imagine the poor tax software. Like they didn't do anything. We were not mean. We didn't try to break them. But the customers at the end who want it on last minute, and everyone does taxes on last minute, or at least half of the population, including me, right? Whoever wanted to do in the last few days, print their taxes, they couldn't. That's kind of impact. What was funny or interesting that both Microsoft and tax software knew that this is an important scenario. We tested that. We tested printing on that particular software because it was one of the important applications, except we printed it, into PDF, and that worked. What didn't work is when you send it on the real printer. Now, obviously, in your CI, you don't want have printer attached that kind of every now and then kind of prints out something and there's somebody checking that. There's one company actually, I was giving this talk in Brno. Actually, there's a company, the Visoft. They are specialized in drivers for printers, so they do that. But I think they're the only exception in the world, or almost one of few. So normal people don't do that. What the key takeaway from that was actually sometimes you have to be extra cautious around specific days or certain kind of critical days, which is kind of, when you think about large, e-shops, they know that for years, right? As soon as there's like shopping season, like which starts usually in November, like it's the whole December, or first half of December, but usually in November, a friend of mine in an unnamed Seattle-ish based, large e-shop, like basically said like, hey, November, I'm done, I'm gonna come basically to work back in January. I was like, what? You don't do anything? Like, nope, we cannot touch that code because the risk of breaking something and kind of losing the revenue, it's like just not worth anything. It would have to be really something super serious. So interesting part is that .NET framework or even things or operating systems are susceptible to do the same things, right? Except that if you run eShop, like you can control what goes in there or not, including your software. You probably don't do any security patches at that time, or unless they really impact you. It would have to be really, hey, somebody's stealing us money, okay, let's patch it and let's be extra careful. But in .NET framework, like now at certain dates, we have to be a little bit more cautious. Another breaking change actually, which was interesting, this is like our friend Federico, he's an MVP. He is in RavenDB, and actually, this is a story I think from a few months ago. Yeah, I think this is from this year, actually. If you click on the Coursera, you're gonna probably you're gonna see that. They actually ran into that. They updated some KB, something unrelated to, and their .NET Core application suddenly started blue screening, which is like, how do you call your .NET Core application blue screen? I don't know. Anyway, short story long, they found out that actually they just started to blue screening, not them, but their customers, obviously. Again, they were the middle layer. We usually have these interesting stories with these middle layer people in between us. And actually they use the prefetch virtual memory to get some kind of performance, cool performance, and they're probably one of 10 people in the world that use it or something like that. And what happened? Well, kernel memory, kernel introduced a breaking change in there. Because nobody noticed, because whatever software they tested on that, and probably gazillion of software before they roll it out, and then slow rollout, and then everything worked just fine, except those 10 poor people in the world, or software, and they were one of them. So sometimes even though you kind of suspect, so what happened with this, what's interesting is well how the routing works, right? The first thing for them was like, find out like, hey, with this batch, it fails, without this, it doesn't. Who should look at it first? Will you come to kernel as first thing? Like, hey, my application doesn't work, kernel team, fix it for me, it's your bug. Like, that doesn't work that way, right? Poor people, like, well, actually it does. Many people try that, but the first thing they came to us, so we kind of investigated. And it's like, hey, this is not something we could have caused, but okay, let's take a first look. And we had one really smart guy kind of going through that. He used to work in kernels, like he tracked it down, like this is really fishy, and like, yeah, okay, dear kernel team, you're gonna have to look. They looked, they found a bug, they fixed it pretty quickly, actually, like a couple of months, so that was fast. Here's my, probably last, I think this is the last story, or one of the last story, which is pretty cool. This is actually from last year, from last July. When I was, it was a great time in the sense that my family just went to Czech Republic, and I was still in Redmond, so I had free time. I could sleep in theory. I couldn't, as you're gonna hear soon, so I had all the time I could on my hands. So what happens actually before I unreveal the July story is actually in January there was a researcher who ran some ML models in Cosmos. And it kind of like sometimes returned wrong results. And somehow they got to us, and first thing from us was like, why do you think it's not working? Like, that's the time I owned all the networking on BCL. I was like, yeah, it sounds fishy. It's like, well, but do you know if it's on client? Because we own clients or on the server side. Like, well, we don't know. Okay, so we kind of poke at them. We came back in there. Eventually, they collected varchar traces from the servers, which if you ever did some serious kind of server-side application, you know that deploying in Azure or whatnot, like, in your production, some Wireshark or these tools, like, is a very big no-no. Like, it's, locked down and things. So it took them a couple of months. And eventually we kind of like got enough information that it's on the client. So the only two suspects, or the biggest two suspects, were either us or the operating system. So where do you start? Okay, you start with the .NET framework, because again, you're not starting always from the bottom, because poor kernel people would solve all the problems in the world, right? And we got some suspicious, we found some buffers, and like, they were a little bit suspicious. Unfortunately, with the logging that we had, and we'd asked them to kind of collect, we couldn't find out what's wrong. So we kind of added more logging and gave it back to them. And then in March, we asked like, so did you get a chance to collect more logs? Like, no, it works. Like, what do you mean? Well, we upgraded hardware and like everything works. So like, okay, well, what do you do if you have no repro? You just know that something is suspicious. And now you remember as well the story about the hardware errors, which sometimes, by the way, happens because of weird drivers and things. So it's like, yeah, you know what, there's nothing we can do. So we kind of put it at ice, except that in May, we got a very similar report. Again, like messed up results and things. And it took, in 2 weeks after that second report, suddenly it blew up. Because suddenly there was like, 5 teams basically hitting the very similar things, weird things, hey, we're getting like, requests mixed up and whatnot. So that was the time when we all hands on deck. So that when I leveraged my fact that I was alone for a while and I had free time. Actually, I did not after this came in. And what was great that one of the teams, actually 2 of the teams worked together, and they brought us a repro. Small repro at the beginning, it kind of, once in 20 minutes it fails. Awesome. It basically shows that, hey, we sent 2 requests and we got like, mixed up responses, which is pretty bad, by the way. And then they played with some kind of like things, tweaks and things, and it suddenly reproduced in 1 minute, which is like awesome. Like you have a, I don't know, of course it's better than you hit F5 when you hit the problem, but even 1 minute for networking is pretty good. When you have standalone small repros, like 2 pages, so that's cool. What was even better is that they got time travel debugging trace, IDNA, or time travel was called before, which is like amazing. Now, let's do a show of hands. Who heard and who knows what the time travel debugging is? Okay, so Dynatrace people and a couple of more, so 5 people. For the rest, it's basically, imagine that it's a thing that records every single instruction in your program what it does. So it has overhead. If you run your application under this kind of instrumentation, it runs roughly 8 times or 10 times slower, but it records everything, I mean everything. So you can open it in WinDBG, sorry, it's awesome tool, but yeah, it's ugly. It's not Visual Studio. So you can open the dump or the trace, and you will see like, hey, here's the AV or access violation, some exception, something that bad happened. You can set breakpoints, including data breakpoints, and then you can do magic command, go back, and basically executes backward, undoes the instructions, and that tells you like, oh, this is where the breakpoint was hit last, in which thread, even like this is the person who read the data, or this is the person who wrote the data. With that, you can get to the root. As soon as we have full trace, magic, like you, with time, will be able to find out what happened. And that's one way how to beat magic. So if you ever are in that situation, look at it. It's freaking amazing. Now it's public for last year or two. It ships through store, but there's lots of cool things about that. So with that, we actually found out that the security issue that we had, or I didn't tell it security. We're gonna tell why soon. Actually, the root cause was that it was HTTP pipelining. Who knows what's HTTP pipelining? All right, nobody, almost. So HTTP pipelining is a simple thing. Normally, you have a request, you send it to the server, you get a response. And then on the same connection, you can finally send another request and get another response. Guess what? Performance-wise, you're basically waiting with the second request for the ping there and back. Now, if you're in Azure, somewhere like those are low latencies, but if you have like even the low latencies, it's milliseconds at least. That's ages in computer science, right? So the HTTP pipelining is basically a thing where you can send one request, and before you get response, you can send through the same pipeline, for the same connection, another request. And you're guaranteed that the server will respond in the same order. That's all. Magic, simple. So you kind of remove the waiting on getting the first response before sending the next one. Simple. By the way, the bug that we was there 13 years, and suddenly out of the blue started kind of kicking, which is interesting. We're going to talk about that. So what was the bug? The bug was if you had at least three requests, and it was about cancellations. So if the algorithm there was like, hey, if you came and canceled the request number 1 on the connection, we basically said like, yep, we're done. Because the first response that's gonna come, the request 1 is cancelled. Why would I drain it? Why would I kind of read it and wait for the next one? Like, just done. Like, kill the connection, restart the request 2 and request 3 somewhere else. Easy. Now, if it was the last one, what did we do? We said like, you know what? Let's remove the last one from the queue. And let's wait on the first 2 and then mark the connection for like kill it after you get the 2 responses. So we get response 1 and we get response 2. And then we killed the connection. Easy. That worked. What didn't work if somebody came and said like, hey, this middle request. By the way, if you're canceling the middle request, something is weird. Either each request had to the same server, by the way, because it's per connection, had different timeout, which nobody does in practice, right? Or the client or whatever you send, you send like backend probably of some, on some backend machine, was so overloaded that more things were cancelled, but the cancellations were not processed yet, and you were lucky to kind of process the request 2, which was this case. Well, in that case, we removed it from the queue and then marked the connection, the connection to be killed, to be kind of destroyed afterwards. Now, that's not quite right, because you get response 1, all is fine. Then you get response 2, and because you have nothing, the next thing that we have in request is request 3. You're gonna say, hey, request 3, here's your answer. Boom. What happens if you give wrong answer to different, or answer to different requests? All bad things can happen. Imagine that the request was something, some server saying like, hey, did I store this data? And then says like, yeah. Oops, it was different response. What it was no. So they tell us easily, right? To make it worse, imagine that it's multi-tenant server, which actually one case was, one unnamed service. When you say like, can you please give me data about customer X? And you get data about customer Y, and you show it to the customer X. That's not good. There were apparently people like, oh, have been hacked? Like, no, there's just a bug, sorry, move on, nothing to see. We're gonna fix it. So we have a funny thing that good thing for us. Somebody was smart when they kind of implemented that. There was like disable, because they didn't quite trust it. So it took 13 years to kind of prove them right, but we had a workaround to disable that. So it had perfect impact, because if you disable the pipelining, suddenly you have the delay waiting on the request. You cannot kind of pipeline more requests in the same pipeline. But honestly, it was like 5–10%, so it was okay. So we worked on a fix. We were verifying the fix, and after 4 hours, boom, same symptoms. I was like, what's happening? So we got back. To make it funny, the repro was extremely sensitive to when it reproduced with the 4 hours. So for example, it reproduced whenever there was like certain network load in Azure. So whenever I had time, because I was like managing the team, I was like managing the partners because they were freaking out, like, you know, you don't have a fix, when are you gonna have it, like every day, a couple of times, right? So after 5 o'clock, you know, family's gone, like you have time to dig into that, I run the repro and nothing. I was like, I felt really dumb. I was like, okay, I have team, they will take care of that. Turned out that it was not me, it was just that it was much lower chance to actually hit the repro after normal working hours. So don't work extra hours, that's one maybe key takeaway from that. To make it worse, the time travel tracing, we tried it, unfortunately it changed the timing so much that it didn't hit the repro. So oops, that didn't help us. So we kind of remembered the suspicion from the January about the buffers again. And we kind of gave them some, we gave them like more logging, I believe, or something. Anyway, at the end of the time, we really found out a bug like in buffer management, lifetime management on the sending side. Because what we did, we sent a request, and before it hit the network in OS, we reused the buffers and used it for another request. So when the first request was sent, it was already a request from the payload from the second request. Oops, and that was 5 years old, by the way, in 4.5.2. What was awesome, we had actually, we found that we wanted to try to find out like what triggered this thingy. Why suddenly out of the blue, this kind of like, buffer management pointed up. And we had a great team, Skype, like, they hit the repro and they were able to say like, hey, we have fail rate 13%, and because they upgraded to 4.7.2. And when they downgraded to the old version, the fail rate was suddenly like, sub 1%, which like they didn't care about. So we worked with them and told us like, yeah, you know what, just give us the bits, whatever, and we can test it out. In 24 hours, we can run it in production. So when you hear the like, when you test, when I don't test, and when I do it in production, this was us. Because on the small repro, we were not, we didn't know if actually we were hitting what's hitting in the live. On the live cases. So we kind of gave them the bits, we did almost binary search, and then found the bug that actually changed that, which was changed in 4.7.1, which funny enough, it was actually around the same problematic area where the bug was. And it was something like, there was a function basically, and originally we kind of released the buffers back, release the buffers back at the end of the method, and we moved it somewhere in the middle of the method. The right fix was move it even up, very high up, but the fact that we kind of made the window kind of shorter or something suddenly triggered this hidden bug. We don't know why. We kind of tried to look at that, and it was a little bit counterintuitive, but anyway, such is life. Interestingly, we did extensive code review. We found actually similar bug as well on the receiving side. So this was, buffer lifetime management. So when you look at that, and it's the same symptom, that thing it had similar symptoms, which means it mixed up the responses. Because again, the same buffers. Like before we read the response, some other response kind of overrode it, right? What was interesting that we hit basically 3 almost independent bugs at the same time. Quite a lot of customers hit that at the same time. It was like 10. And the only thing that we come up with was like probably Spectra and Meltdown fixes were kind of rolled out roughly in January or something, which actually doesn't explain the Cosmos DB, which was even prior to that. So anyway, or the only thing that we kind of thought that maybe it's some kind of magical thing. Like I started to believe in magic. The lesson learned from that is like sometimes weird coincidences will happen. Like, old bugs, one was 13 years old, 2 were 5 years old, and just at the same time they decide like, yep, it's time to give you a hard time, and they gave us. So this is the last story, I hope. It's about typizations. So it's very quick. Once upon a time, there was an unnamed service in Microsoft, and I had a friend over there. And he came to me that, you know what, these architects over there were arguing very passionately about like, should we use list or array as a data structure for this? Am I gonna save like 2 instructions or 1 instruction and that stuff? And he comes to them and tells them like, guys, first of all, this data structure will have like 3 to 5, in normal cases, elements. It's just 99% case. Why are we talking about this, couple of instructions? Okay, you want to hyper-optimize. By the way, did you notice that our service, imagine like backend of something like bank or, I don't know, SharePoint Online or Exchange or something large, right? This thingy, by the way, has 3 hops between servers. That's milliseconds. You're arguing about instructions like micro, sub-micro seconds. Why? That's a lesson that I would like you to come away from this, is that sometimes people just jump to conclusions and like, oh, I'm gonna micro-optimize this, I'm gonna do this. They kind of start prematurely optimizing. And they can be super smart people sometimes. And it's extremely hard to kind of step back and say like, does this matter? Like, is the instruction here and there gonna really help your customers? Shouldn't you be focusing on removing one server hop? That's gonna make a difference, that you're gonna see. One instruction, I don't think that anyone will see it ever. Alrighty, just recap, 45 minutes, I'm on time. So first of all, the first story is that debugging hardware issues is costly, and it's worth sometimes when you see something suspicious to just ask people like, hey, does it happen only on one machine? Some bugs sometimes happen once in a long time, 17 years or something, and spec bugs, like the sooner you are in the development cycle, the harder it is to fix. So the spec bugs are extremely hard. It was the metadata format bug, anything and really anything can break your application, so innocent changes, they can move things, and sometimes the impact can be large. Like, imagine the story about the tax season, right? If you break the right thing at the right time, it's bad. And one of the two key things I would like to having a small repro is so it's time saver. So many times on our CoreFX repos and other .NET Core repos, you will see that we're asking like, do you have a repro? Okay, good, that's the first step. Great, and it can be large, that's okay. And the next step, like, do you have a small repro? Because with that, you can do magic. Remember the case of networking when we had the small thing? Just the fact that we could run it and see, hey, I can verify my fix works, and then boom, in 4 hours it fails again because it discovered another bug. Like, that's gold, And yes, it takes time, but it's gonna make everyone's life so easier. And I've seen cases when people on .NET Core are like, well, you want from me small repro? Well, it's gonna take me like 2 days to do it. Like, well, should I spend the time to doing that? Because guess what's the first thing I'm gonna do if I get a repro? Minimize it, just to throw out things, I think that our friends from production diagnostics tools know that as well, right? When they come like, oh yeah, in this kind of large thing, something happens. The first thing is like, can you like a little bit more, because we know that we're dealing with one product, two products, two libraries or something. But it's hard. It's time consuming. IDNA and time travel tracing is lifesaver. If you ever get into that, just use it. It's awesome. It's amazing. If you repro under that. The second thing, premature optimizations. Don't argue about instructions when you don't know if it's the thing that's going to impact your customers. And sometimes, there's just magic. There's no way around that. So thank you very much for being here. Please remember the feedback. We're gonna send a survey, and if you want to kind of send feedback to me or to my colleagues as well, Twitter DMs, email, hunt us down here. We're more than happy to chat. What you liked, was it rushed, hard to understand, boring, whatever it's useful. And just remember again about Steve. He's the guy who has very similar ideas as me apparently on this, and he's not the only one. It's really valuable for the speakers to know what's the constructive feedback. So if you can come up with something more than like, it was awesome, but it was awesome, but next time can you speak a little bit slower? That would be extremely valuable. Thank you. I could go for 45 minutes after all.
Yeah, it's nice. It's nice. Was brauchst du? Ja, voll. nehmen einfach das.
Ist das das? Ja.
Das ist für Streaming.
Ja.
Für den Raum kannst du das.
Beides nehmen. Ja, jetzt beides.
Ich würde vorschlagen, ja. Also das unbedingt. Egal. Beide funktionieren, oder? Für Streaming.
Okay.
So next one is Viktor, and after this we will do a quick break, and then we will have the panel discussion. So yeah.
Thank you. Okay, hey guys, my name is Viktor Hofer. I work for Microsoft at the .NET team. I started in March 2017. If you would ask me, I'm currently assigned to some areas like infrastructure, that also involves .NET Standard, Arcade, the regular expression engine in .NET. So funny thing, I also had a talk in Vienna 2 weeks ago, and we had a funny Twitter conversation about binary formatter afterwards. So if you have any questions regarding binary formatter, don't ask me, but ask my colleague, Levi Broderick. I also work for .NET Framework from time to time, depending on customer issues. For example, just yesterday, I submitted a fix for a customer who had issues with binary formatter, which does not mean that you should ask me. Okay, let's start the discussion with a question towards you. Funny question, how many of you test code? Raise your hands. Okay, yeah, that was a funny question. How many of you have more than 1,000 tests in your customer application, in your business application, whatever? Okay, like either people are not participating or just half of the hands. Who has more than, let's say, 1,000 tests? 100,000 tests? Okay, nobody. Like 1 million tests, nobody has. Okay, so at .NET, like in CoreFX, which is my example of the talk, we have about 7 million tests, which run per pull request, which means which run every 20 minutes, let's say. So for us, testing matters, and efficiently testing matters as well. Trigger? Nightmares? Okay. Okay. Okay, so that's the reason why testing matters for us in CoreFX and for .NET itself. And my colleague Karel told me that I think we run about, if I can remember correctly, we run about 500 million tests per day, just for .NET Core. So let's quickly summarize what I'm going to talk about. First, I will mention how CoreFX itself started, where we are today. Then I'm going to talk about testing and why it matters. I already briefly talked about that. Then I'm going to mention Azure DevOps and Helix, which is a custom tool from our .NET engineering team. Then I'm going to talk about continuous integration and how we, the .NET team, understand continuous integration. Then I'm going to talk about issues that we are currently hitting, and probably some solutions that we will find over the next months. So let's talk about CoreFX and how it started. So CoreFX was open sourced in November 12, 2014. We only had a very limited set of BCL libraries like immutable collections or system numerics vectors. funny thing, because I looked at the Git commits, we initially started with app.io as our build system and CI system, and quickly afterwards migrated to Jenkins in 2015. Jenkins is the CI system that we used for several years, and just recently, 6 months ago or so, migrated to Azure DevOps. And another thing that we had initially was the fact that we use the same agents for building and for testing our code, which means what you usually have when you run your CI code, when you run your code in CI machines, you use the same machines. So today, CoreFX has a rich set of BCL libraries, and BCL means base class library. We have about 192 libraries, and the newest one is System Text JSON, which you can find in .NET Core 3.0. We have about 4.5 million lines of code and 21,000 files. And just to get a feeling of the number of lines of code, the Windows operating system has about 50 million lines of code. So if you want kind of comparison, we are like 10% of Windows. I don't like that comparison. Now we use, as already mentioned, now we use Azure DevOps for CI and CD, continuous delivery. We have a large set of build and test configurations now, which I will show just in a minute. And we have dedicated agents for testing, which means we don't use the same machines for building and testing. And we use for that we use our custom tool called Helix. So, funny thing, I found that picture on the internet. It's about excuses for not testing software. So I already asked the questions, how many of you run tests in CI? So let's start with another question. Why do I need to test my code? First thing, everybody makes mistakes. Second thing, how do you know it runs perfectly? The next thing is, but I don't know what to test. Okay, test all the things. Yeah, that's more fun. So the next slides are going to be marketing slides. So let's quickly skip over those. What is Azure DevOps? Azure DevOps is a developer operations product which consists of 5 major features. One of the features is Azure Boards, which you probably know, which is just a work item backlog where you have your issues and your bugs listed. The next thing is Azure Pipelines. Sorry, Azure Boards. Oh, okay. The next thing is Azure Pipelines, which is the CI system that you use when, for example, when you connect your GitHub repository with a CI system, then you use Azure Pipelines and you get the badges at the bottom where you see your builds are succeeding or failing. The next thing is Azure Repositories, which is the source control container. Either you can use Git or you can use Team Foundation version control. The next thing is Azure Test Plans. I think that was previously the automated testing and UI testing. And the last feature is Azure Artifacts, which is a nice thing when you want to have your own NuGet feeds. Then you can, so for example, I guess, how many of you know MyGet and what it is? Okay, so MyGet, MyGet is like NuGet, but you can have your own feeds and you can just point customers to your private feed so that customers can test your changes quickly. So Azure Artifacts is the same thing. You have your own CI/CD feeds, and you can just easily plug it into your whole ecosystem of tools. So I already talked about those slides. So this is what Azure Artifacts look like. Here you have your NuGet packages, and yeah, you can just see the metadata on it. So we will skip the Azure DevOps demo just for the sake of time. So let's talk about Helix and what it is. So Helix, as I already mentioned, is the custom tool that we use at in the .NET team for testing our code. What is Helix? Helix is a massive parallel general purpose processing and result aggregation system, which means a lot and nothing. So what do I mean by that? You can send any kind of work items, and Helix just runs those work items and tells you if it succeeded or not, based, for example, on the result code, like the error or exit code, or on, for example, test results file generated by XUnit. Helix is using a REST API and also offers an MS-Build SDK. In CoreFX, especially, we use two payloads for Helix. The first payload is the shared framework, which is the entire runtime, which consists of assemblies like system, runtime, system text regular expressions and those. And the second payload that we send to Helix is the test app's output itself. So for example, we have tests for system text regular expressions. That assembly is called system text regular expressions.tests. And the whole folder where we have the test library, where we have the test data, that stuff is submitted to Helix, and then it is run there and is using the shared framework, which is the BCL, the runtime, which is only submitted once, and runs those tests based on the first payload, which is the shared framework. Probably that's a bit, it's hard to explain, but I'll try to give you more pointers soon. And just one more thing, what we do currently, I already mentioned that. When I created my talk, in the beginning of this month, we had about 12 million numbers of tests on more than 30 configurations. We had to disable a few because we had some issues with one configuration, but just that you understand, we run about 12 million tests in less than 40 minutes, which is pretty impressive. So let me explain what Helix is with some drawings. Drawings do not work. Okay. Could you see me? Yeah, you can see my screen. Okay, perfect. I wanted to ink something. Yeah, okay. No, that's not it. Okay. Oh, okay. My drawing is already here from my last talk. So what is Helix? For example, you have a library like system text JSON. You send those libraries, those test libraries to Helix as work items. This is one work item, this is another work item. Then we also send the shared runtime, which is just the runtime, all the assemblies of the runtime, and together with the runtime, let me see. Okay, horrible. Runtime and the test output, together those are executed at Helix, and Helix runs those on different agents and machines, and then it reports the result back to Azure DevOps, and then you have your CI statuses. Okay, so let's continue. How does that look like? For example, okay, this is the only slide with MS-Build syntax, just as a disclaimer. For example, here you have a Helix command based on when we run on Windows. You have the payload, which is the shared runtime, and we just call a run test script. On Windows, a CMD script. On Unix, a shell script. And then what that run test script looks like is just an invocation of .NET exe, with test, and then the test library itself. So this is really pretty straightforward. And what Helix does, it just runs that command and then reports back the result. But the fine thing is, it's massively parallelized, so it means that it can, for example, send the one test library to one machine, another test library to another machine, and then you get, after 40 minutes, you get all the results back and it ran about 12 million numbers of tests. So let me quickly show you how Helix looks like. Okay. Okay, so this is currently the dashboard of Helix. Here you can see all the test libraries that we have in CoreFX, like for example, system app context tests or system win32 registry.tests, and those are run on different configurations that you can see here, like all the Unix configurations, also the OS X configurations, and then a big number of Windows configurations. And as you can see here, most of the tests, sorry, I'm not used to that. Most of the tests succeeded, and just one test further down, let me find it, just one test failed here. Yeah, and then Helix results reports all those results back, and also the failing one, which we can see here in Azure DevOps. This is the Azure DevOps UI. Here you can see that one test failed. Okay. So let's continue. As I already mentioned, in CoreFX we have a big test matrix, a big matrix of where we run tests and what we support. For example, this is .NET Core 3.0. We support a huge number of configurations on Unix, like on Fedora, Debian, Ubuntu. I'm not going to read that. Just that you get a feeling of what we support. Recently with .NET Core 3.0, we also added ARM32 support on Windows, on Nano Server. So, as already mentioned, what do we understand as the .NET team of continuous integration? We have different layers of protection in continuous integration. For example, we have pull request validations, which is what you usually use. When you submit a pull request, a build is triggered, and then you can see the status on it. Then we also have rolling builds, which are also called master validation because they mostly run on master, which means when you merge a PR, you get a commit into master, and then it triggers another build and another kind of continuous integration validation. Then we also have so-called official runs, which are runs not on the public organization of Azure DevOps, but on the internal organization. The only reason why we have those official runs is because we need to sign our binaries, and signing is because of a security concern. We can't sign our binaries in public, so we need a code mirror where we mirror all our code from GitHub to a private repository, and then run and then build our whole product in those official runs. And then the fourth thing is what we have is outer loop runs, which is a funny concept. I'm not sure if you also have something similar. In CoreFX we have the segregation of inner loop and outer loop. Inner loop is just running all the tests as you are used to, but outer loop is a different layer of running tests, which means, like for example, networking tests or I/O tests or cryptography tests, which can fail and we can't really control because, for example, of networking or because of CPU cycles, which would be too much for continuous integration. Like when you run a cryptography algorithm, which would take about 120 minutes, you can't easily run that in continuous integration per pull request. So we have that segregation, and those outer loop tests we just run scheduled, for example, once a day. So, as already mentioned, the pull request validation is the first layer of defense. Per pull request commit, we run those set of tests. And then we have a limited test matrix because we can't run all the configurations for every pull request because it would just be far too costly. Because pull request builds are the builds that are running most of the time, and we only have a limited set of hardware in our labs, which is funny because we are Microsoft, but still we need to calculate our costs. So, for example, for ARM32, like those mobile devices, we currently have about 150 devices, and if we would run ARM32 tests on every PR in all our repositories, those machines would just be fully blocked all the time. So let me show you one pull request run. This is one of the let me see. Yeah, this is a pull request run. Here Yeah, that's a pull request run. We have about 7.5 million tests, which we run per pull request. We have one failing test, and here you can see, this is just the test explorer of Azure DevOps. Here you can see the summary of it, and here on the build UI you can see the configurations that we currently support in CoreFX, where we build our repository, and then per one of those legs we send. We trigger the Helix API, and then execute those run tests per test library. Okay, let's continue. So the second thing, as already mentioned, is the rolling build. It's the second layer of validation. We do it per master commit, and there we run the full test matrix, which means also for example, the ARM32 machines, which we can see here. Here we have one. Now we have more tests than before. So let me show you. Here we had about 7.5 million tests, and here we have 8.5 million tests. You can also see here on the left side that now we run on ARM64 or ARM32. It should be somewhere. yeah, for example, here on Linux. And the second layer of validation is pretty important for us because if we don't test on all the OS variants that we support, we could not ship our product because we could not have a confident choice. So the next thing is the official build, the official run. As I already mentioned, we have a code mirror. Oh, sorry. We have a code mirror from the public organization to the internal one. We do that per master commit, so same as the rolling builds. We only use that for, so we don't run any tests there currently, we only build there. We use it for signing, and signing also takes some time. Currently it takes about 40 minutes per commit. And from there, from those official runs, we produce the nightly and the final bits that you can then download on our websites. So the outer loop runs, the outer loop runs are resource constrained, like networking and cryptography. They're scheduled, and how we do that in CoreFX, how we mark tests is we just add an attribute to the test which says outer loop, and then probably also point it to an issue which explains why this test needs to be an outer loop test. So some stats, just that you know what we're talking about at what kind of scale. In CoreFX, per day, usually we have 15 to 25 commits merged into master. This is just a rough estimation. We have 25 to 45 builds triggered by pull requests per day. We have 6.5 million tests per pull request. We had 12 million tests per rolling build. We have about 5 million outer loop tests. And if you sum all that together, you will see that we run about so in CoreFX alone, we run about 500 million tests per day. And I think Karel told me that at a different event. If you sum all the repositories of .NET, we run about 500 million tests per day. 500 million, yeah. Okay. Sorry? 11. Pardon? 11 billion. Okay. Fair enough. Okay. Still a big number. So let's also quickly talk about test flakiness and what it means. So we use the word flaky for when we have some tests that don't have a pass rate of 100%, because which means any test which fails at least let me try that again. If you have any kind of test that is not guaranteed to pass all the time, then you will see all the time failing builds just because of those kinds of tests. Because when you run about 6.5 million tests per pull request, you can estimate how small the number must be for how high the number of pass rate must be that you don't have any failing builds. So what we are trying to do in CoreFX is to have a pass rate of 100% for all the tests, and if a test can't be guaranteed to be always succeeding, we either put the outer loop attribute on it, or we just disable the test and investigate further. Another thing. So yeah, sorry. Looking ahead, what we are currently facing, what kind of issues we are currently hitting. We run a lot of tests currently across repository boundaries, because in CoreFX we have all the BCL, all the base class libraries, and in CoreZLR we produce the JIT, for example, the GC, all that stuff. But they again need to run all our tests from CoreFX just to be certain that their changes are not requesting something, which means we are running our tests twice in the run repository and in the other. So we are trying to solve that by different approaches, which I can't go into more details at this point, but this is going to happen for .NET 5. Also, we are going to test with different modes, like a GC stress mode or different intrinsics, like hardware intrinsics. What we are currently doing, we are always running all the tests, but if we make a change in an isolated space, we don't need to run tests in another isolated area. We're going to address that at least partially. And because of .NET 5 and what Alex already explained with Mono, we have different runtimes going forward, like we have Core CLR and we have Mono VM, and we need to test all our tests. We need to run all our tests with both runtimes, which means we would need twice of the amount of hardware, which would be unfortunate because we can't easily just double our hardware, but we will find different solutions for that. So just to summarize what I was talking about, first thing, of course, you need some tests, but it easily showed in the beginning that you are aware of that. And yeah, I want to thank you. If you want to reach out to me, I'm on Twitter, pretty active. Yeah, just once more, test your code. Try out .NET Core 3.0, which we're going to release pretty soon. For example, I'm not sure if we already released Preview 7, but we're going to release that pretty soon. Or did we already? Okay. Nice. Today? I don't know. Okay. Okay. And if you want to, you can contribute to our repositories. We are pretty active in CoreFX and in CoreCLR and all our other repositories. And usually when you post some issues or questions or whatever, we try to respond. I think we did not respond to one of your issues, right? But okay, okay, okay. Ah, yeah. And one thing that I forgot about. So this the talk is over at this point, but just because I wanted to again mention why testing is so important. One thing that I hit just a few days ago was a bug in Coverlet. I'm not sure if you know what Coverlet is. With Coverlet, you do your code coverage instrumentation, so you know how much your code is measured and covered. And we hit a funny bug, which caused a null reference exception and crashed the whole coverlet assembly. And what it was, the reason why it was crashing was because it was always only checking the get method of a property that we create behind the scenes, but never the set method, which means, let me show you that, which means, for example, when you have, okay, this is VB code, but if you have a property that you can see here, this property is called internal command line, and this only has a setter, but no getter, and Coverlet only always tested with the get method. You always use the get method, and did not use any question mark, dot or so. So it always assumed that the get method is not null, and this resulted in a lot of crashes. Yesterday I submitted a PR, which just either checks the get method or the set method, whatever is not null, and then the code coverage worked again flawlessly. So this is one example where you should test your code. This would not happen if you test your code, and if, just one more thing, if one of the repository owners like Marco or Tony are watching, Coverlet is a great repository and they are doing a great job, but still we need to get better and we need to test our code. For example, in CoreFX, we currently have a code coverage number of about 60% of the whole BCL, and we are also trying to get better in the next year. Okay, so again, thank you for listening. If you need anything, just ping me. Thank you.
So let's do, doesn't work. Anyway, so let's do a 5 minutes break very quickly, and then we have a final discussion. So prepare all your questions.
Sehr gut. Danke, danke.
Ja, sehr infrastrukturlastig.
Ja, passt schon.